Hello, I'm David Bell. I'm a product marketing director at Cadence in the Tensilica IP team. And today I'll be talking about low energy on-device AI processing, and in particular the combination of the HiFi 5 DSP with the NNE110 neural network engine. I'd like to start by introducing a little bit about on-device AI. So AI, as everyone knows and everyone says, is becoming much more pervasive in the industry. It's becoming integrated into many products we use on a regular basis, even whether we know it or not. In many cases, the AI implements a key feature with which we're interacting directly, and so it's obvious. Could be responses to natural voice commands that's triggering a function on the end equipment, but it could also be something that's deeply embedded in the product, and you don't really have any idea how or where it's being implemented. But in any case, AI is dramatically changing the way data is being processed, as well as the types of data that can be processed, and bringing many new features and new products to market. Some of these are shown here. Many of you may have some combination of these products, smart speakers, different types of hearables, AR/VR equipment. Many of these are bringing AI processing directly in with more general purpose signal processing, and we are able to take advantage of the combination of the HiFi 5 and the NNE110 to make these even better. So if we look at how the NNE110 works, it's actually in conjunction with a DSP. So one of the combinations that we released, actually the first combination we released, was with the HiFi 5 DSP, which has a large number of features and a high degree of processing capability in and of itself. It can perform up to 32 8-bit multiply accumulates per cycle. There's an option to add floating point capability, vectorized floating point capability, and it's really optimized for high-end audio and speech processing. But as we're adding AI into the system, it's important to further enhance its capabilities in a system that requires a heavy degree of computation. So the HiFi 5 all by itself can already process neural network inferencing. So we support TensorFlow Lite for Micro frameworks on the HiFi 5 DSP, and that's the same framework that we take forward when paired with an NNE110. So what the NNE110 has is it has a scalable compute block. This is something that you can configure at RTL generation time. We allow a selection of 32, 64, or 128 8-bit multiply accumulates per cycle, peak performance. And this machine is really geared for less than a quarter tops performance. It's not a high-end inferencing engine. It's really geared towards low energy inferencing and as a companion to the DSP to make the DSP processing even better. But the compute block supports network sparsity, so it will take advantage of zeros in the data as well as in the weights, and it will actually skip any unneeded multiplies by zero type operations. It does support weight compression, so offline the weights can be compressed into the smallest memory footprint possible, and then as the weights are being consumed in the compute block, it'll decompress those weights on the fly before processing it with the input data. The compute block itself will support many different layer types, so fully connected layers, convolutional layers, average and max pooling layers, LSTM, etc., and actually many more. So this efficiently offloads the processing entirely from the DSP for many of these operations. Or when needed, or if a new operator does come out that's not fully supported in the hardware, the DSP can be used in parallel with that to augment the processing of the NNE block. But it is important to note that it's not only a hardware engine, but we also have a full software environment along with this solution. So we have libraries, we have the framework, and we have many tools that go along with this to ease development and integration into your system. So if we look at a smart speaker example, just to illustrate one type of processing that can be done with this combination, we see the overall signal diagram, and the portion here in red is being implemented with AI or machine learning. And in this case, we're looking at noise suppression and keyword detection. So this would be part of the Ingress Path from the microphone into the system, and this would be the always on or the active part of the system. And the remainder would actually be off whenever possible. So data would only be sent to the host, in this case in the cloud, after a valid keyword is recognized, and the path back out to the speakers would actually be off when we're not doing any kind of play out. So the speakers would only be activated when responding to a command or when a play out activity is actually activated. So we want to look at the functionality here in the noise suppression and the keyword recognizer and how the NNE can help the HiFi 5 to perform this function. But one thing to point out is it's actually not a solution all by itself. It's not just an AI solution, but it's actually integrated in with the overall application. So part of the signal chain along with more traditional signal processing functions. Noise suppression is something that's been around for some time and is done in traditional DSP using adaptive filtering techniques, but it is a function that's been migrating to AI. And the reason for this is to take advantage of the processing capability that AI brings to solve a problem of multiple environments in which noise needs to be suppressed. So in the case of the smart speaker, it may not operate only in a quiet home environment where there's an individual speaker, an individual person talking to the speaker, but there could be multiple people, it could be outside, there could be multiple conversations, background noise and music, and so there needs to be ways to filter all of that out so that the speaker can listen to the active commands. So we'll look in this case at an LSTM network, and here we're comparing the cycles per inference being done on the HiFi 5 standalone, because again it can perform this by itself without the engine, to the combination of the HiFi 5 with the NNE 110. And in this case, we see a reduction of more than 3 times in the cycles required per inference. Similarly, if we look at the energy consumed, which is energy consumption is a critical component for any battery-powered equipment, we also see a greater than 3 times reduction in the energy required for the inferencing. So this gives a degree of flexibility to the system designer to optimize either for latency or for energy or for some combination of the two. One thing to point out is that the application, the embedded application, would actually look the same whether it's on the DSP by itself or the combination of the two. The offloading to the NNE 110 is actually under the hood and not something that's explicitly dictated by the programmer. If we look at a different type of network, in this case a CNN-based neural network, still noise suppression, we see an even more dramatic offload. So here, the overall cycles required for this network is higher, but the efficiency with the NNE is even better, and so we see more than a 10x reduction both in terms of cycles per inference and energy per inference. And what we typically see is somewhere in between the two for different types of networks, between the 3 and 10x range for efficiency with the offload. But there is quite a bit of variability in networks, and this is a very dynamic space with lots of different innovations, and so that range is something that we typically look at. So circling back to the ingress path, so again, this is the always-on active listening portion of the smart speaker example. We need to be able to efficiently mix the traditional signal processing functions with the ML functions. So what we see is the machine learning functions sit on top of the TFLM, or the TensorFlow Lite for Micro interpreter, and this is below the hood of the application that the customer would program. But this interpreter will take care to go through a mapping operation, which will decide whether actually this is decided by the offline NNE compiler, but this will determine whether functions are pulled from an optimized DSP library to be processed on the DSP, or will be directed through the NNE driver to be executed on the NNE 110 hardware. So again, this looks the same whether it's a DSP-only application or the DSP plus NNE. Basically, that is hidden by this operator mapping layer, which will take care to either direct the operation internally or feed it outside. We do have a basic framework that allows the mixing of your signal processing tasks with your machine learning tasks. That's the Extensa Audio framework. This is an OS-agnostic framework, and by default it will work with the Tensilica XOS operating system, but it can also be run with FreeRTOS or a scheduler of your choice. But this allows an easy environment to integrate multiple tasks, and it allows a great deal of visibility to debug your embedded application. For the inferencing, this can be debugged at an operator level, which gives you a great deal of visibility in your embedded target that you can compare with your offline inferencing model. So in summary, when the NNE is combined with the HiFi 5 DSP, what we see is a much more efficient, high-performance inferencing engine that can do an efficient blend of traditional signal processing tasks along with machine learning tasks to bring innovation to your embedded design. The RTL is released as a full subsystem with both the DSP and the NNE, fully verified, taking in any configurations that you may select both for the DSP and for the NNE, and that enables an easy integration into your SoC environment. But most importantly, it brings efficiency improvements, low energy as well as low cycles required to do the inferencing that allow the DSP to be free to do other tasks in the signal processing domain. So both the DSP and the NNE are highly configurable. Again, the DSP can be configured with a set of predefined options from Cadence, or it can be extended through our Tensilica instruction extension language, where you can add custom instructions, custom data types, and really build out a tailored solution for your environment. And the NNE110 has some configurability in terms of peak performance, as well as internal memory sizing to meet your performance and power needs. With that, we can close. Thank you.